Hello students, in this video we will solve a numerical on finding self-inductance, mutual inductance and coefficient of coupling between the two coils. So let's read the numerical firstly. Two identical coils P and Q, each with 1500 turns, are placed in parallel planes near to each other, so that 70% of the flux produced by current in coil P links with coil Q. So please pay attention to the word identical over here. So two coils are identical in all respect to each other. It means that 70% of the flux when is produced by current in coil P links with coil Q. It also means that when coil Q will carry current, it will produce some flux, out of which 70% will link with P as well. So whichever coil carries current, 70% of the flux produced by that coil is going to link with the other coil. This is because the two coils are identical in all respect. Now, if a current of 4 ampere is passed through any one coil, it produces a flux of 0.04 milliweber linking with itself. Find self-inductance of the two coils, the mutual inductance and coefficient of coupling between the two. Now see, this numerical is very easy once you understand the concept as I was describing. So let's start identifying. Let's try to understand the scenario over here. So see, here are two coils placed beside each other, and flux produced by coil number P links 70% with, or 70% of the flux produced by coil P links with coil Q, or 70% of the flux produced by coil Q also links with coil P. This is true in this case. Now let's identify the given things as number of turns of both coils as mentioned in the numerical is 1500. So as I said, K1 and K2, the coefficient of coupling can be represented as K1 and K2, which is equal to 0.7. And when IP, the current through coil P, is 4 ampere, flux that links with coil P itself is 0.04 milliweber as informed in this statement. Also, when it is said that if a current of 4 ampere is passed through any one coil, it produces a flux of 0.04 milliweber linking with itself. So this statement is true for both the coils. So when current of 4 ampere passes through coil P, IP, that current can be called, and flux that links with coil P, that flux can be called as phi P, is 0.04 milliweber. When we say that 4 ampere is passing through coil Q, we can call it IQ, and phi flux that will link with coil Q because of IQ can be referred to as phi Q, and hence 0.04 milliweber. Now this numerical is very simple because the quantities are identified accurately. If quantities are identified accurately, otherwise you may commit mistakes in this case. So LP is equal to, we know the formula for inductance is N into phi upon I. So NP phi P upon IP. If we substitute these values as identified in the given, we get 15 millihenry. LQ, the inductance of coil Q, is also 15 millihenry, and it was bound to happen because the two coils were completely identical with each other. Now we will focus on finding out the coefficient of coupling. The coefficient of coupling can be easily found out by using the formula under root K1 K2. We know the value of K1 and K2 is 0.7, so under root of K1 K2 becomes 0.7. Mutual inductance M can be found out by using the simple formula K under root LP LQ. So K under root of inductance of coil P and inductance of coil Q. Now when we substitute these values, what we get is 10.5 millihenry to be mutual inductance of these two coils. So see, this was quite a simple numerical where you were supposed to find out self-inductance of the two coils, coefficient of coupling between the two coils, and mutual inductance of this arrangement. And for this the data given was supposed to be understood properly. Had you not been able to understand this statement or this given thing from this statement, you wouldn't have been able to calculate LQ. So to calculate LQ, it was necessary that you should have focused on the word identical. You should have focused on the word any one coil when carries current 4 ampere, it produces a flux of 0.04 milliweber linking with itself. So unless and until you focus on the words in such numericals, you will not be able to fetch proper data over here, and hence you will not be able to solve it accurately in this fashion. I hope you will carefully look for the given data in such numericals and will solve these numericals. Thank you.